of things that I've been looking at. My time at DOE and just in general watching as a research fellow, I kind of watch what's going on in the market and spend a lot of time there. Some of it will be very familiar to you. Some of it may seem like, yeah, that's already happened. But I hope that I'll give you some new information. If you need AIA or GVCI credits, they're available for this. I'd like to start all my talks by just making the point that building energy use is important. Worldwide, buildings use about 30% of energy. It varies quite a bit by country to country. A good example here, China and Hong Kong. China, it's approaching 20% of energy use for buildings now. 15 years ago, that was 10 or less. It is growing phenomenally as they're building cities, and you see that. Hong Kong, on the other hand, is over 60% for buildings. It's primarily a service industry place. There's very little industry at all, at least as far as energy use. And varies depending on how the economy is focused on heavy industry or energy-intensive industry, I should say, or not. So you kind of get a variation there. But U.S., it's about 40% for buildings, and that's been growing over the last 15 years. It used to be 30 and then 35%. And then the 2010 recession hit. And the commercial, which looked like it was going to outgrow that, it just kind of stalled. It hasn't been growing, but we're still building a lot of houses. Industry 50 years ago used to be half of our energy use in the country. But as we've built, with the country population has tripled, and as we build more houses and buildings to do things in, and a lot of the heavy industry that was very energy inefficient is now energy efficient. Transportation has been pretty stable, though. Building use has changed a lot. And when I started my career, we worried about heating and water heating and all that's, kind of the basics in a house. But what's happened now, computers have made it in, they're more than a single digit. But now there are a number of end uses, a full quarter of things going on in the buildings that are in our houses that weren't there even 15 years ago. Stuff like this. I have 20-year-old twins, and they're in college and doing well. But I went and looked on our router when they were still at home, and there were 17 different devices connected to my Wi-Fi. So, phones, computers, tablets, games, the Blu-ray, the TV, just about everything you could think of was all connected. That's driving a lot of that. So we have a lot more electronics in our houses and a lot more smart devices coming in as we move forward. The commercial sector, of course, there's no typical commercial building. An office building can be dominated normally by heating, cooling, and lighting with some ventilation in there. But the sector in general looks like this, still heating dominated. But there are a full third of these small things that are happening in the buildings, and we're going to deal with it. We've got to deal with everything to really push that. And computing and office equipment's already up there. Together, they're over 10% of energy use. But an office may be dominated like that, but if it's a supermarket, it's going to be 50% for refrigeration and freezing, and that's going to be the dominant end use. And that needs to be dealt with if you're working that building site. Yesterday, I talked about climate change, so I'm going to stick a little bit in here on that, just partly because we are seeing changes in what's happening. This is the hottest year. New York Times has a great series of websites that how much warmer was your city? And so 2016 was the hottest year on record. And what you see here in Boise is record high, record high, record high, record high. And that's pretty consistent in most of the locations I look at. The kind of tan background is what's known as the normals, and that's the past 30 years looking at it and compared. So this is setting records above that for a lot of the cases. And but moving forward, this was last year, which was a top 3 hot year. We're not seeing as many of the record. Most of those were already set. But what you are seeing is a lot more warm than would be in the range of normal. I'm sorry, the tan is the extremes. Those are the record. The gray behind it is the normal. So what you're seeing is much more in the spring and the fall and the winter temperatures that are higher than what you would have seen in the past. This. The global data set for temperature around for everywhere starts about 1880. You see the gray spots here, that's where there's missing data for that period. But from about here on, we begin to see that. So if it's blue, it's colder than normal, and if it's red, orange, and red, it's getting warmer. So you can see we had pretty much a little bit of a cool spell until we get to the 30s, and then there's some hot spots that we're seeing, and then the 50s, again, kind of more of a cooling trend for that. Moving on to the 60s, at least for North America, we're somewhat cool. And then 70s as well, some hot spots appearing here and there. And then we get to the 80s and the 90s, and you start to not see so much blue. We start to see the average, you can see the global mean temperature changing there, and it's rising. So over that period, is from the 50s to today, we've seen almost a degree change worldwide. Now, you see there are cold spots. There, some of that ice melting in Greenland's probably cooling the North Atlantic. But there are other cases for like that. But we're seeing largely, not uniform, but warm temperatures that we haven't seen before, and they haven't been seen in the record for a long time. Other thing that's happening is the amount of things that we're using today, apps and devices that weren't around 15 years ago. So, for example, 400,000 apps are downloaded every minute globally. Users send 500,000 emails or tweets every minute. That's 188 million emails a minute. So these are things, I mean, Skype, Instagram, Airbnb, Uber, Venmo, Tinder, Tumblr, Twitch, you know, all these various things that weren't even around much. We are now, with our devices, being able to do that. So that instant ability to get more information really has been changed. These guys wrote a book about disruption. And what they said, we are kind of in a technological change that's going on that's changing the globe. There's an urbanization change. We're getting mega cities that are 10, 15, 20 million people or more. Technology, you're seeing accelerating because technology kind of feeds on itself and you get the next innovation pretty quickly. We also have an aging world. Japan and China already have a problem that they have fewer young people than they have old people. And so Japan has already been a situation for a while that they don't have enough working age people to pay for the benefits to the old generation. And China, they now know that they have a similar situation. They put the one child only for a while, and it did slow the population growth. The problem is now they have a lot of, where you have two parents, there's only one kid that has to cover that going forward. So they know have an issue. Also, getting old is not what it used to be. I can remember my grandparents, when they turned 60, they were old. I mean, they looked old, they acted old. And now, just partly lifestyle changes and also medicine, there's a lot more that we can do today that we can't. That wasn't possible 20 years ago. Global connections. My company operates in a lot of places, but it's not unusual for me to have calls with somebody in Europe, somebody in Asia, all at the same time, and it's real time. Skype and all these other systems that really work that. So people are talking. It's no longer, you know, you have to write a letter and then you wait for a response. You're able to get something instantaneously. And that's true trade, finance, and data, all very liquid and very movable today. So in my work at the Department of Energy, I worked on trying to push the commercial sector towards zero energy. That was the goal that we were pushing at the time. And that started about 15 years ago. But here's some of the things I saw. At that time, there were no owners other than the federal government that owned 1% of the commercial floor area. Now, Walmart does. They have enough buildings in the country that they are 1% of the floor area, also 1% of the electricity. And for them, it makes a big difference. That centralization means they can focus people, very talented people, on looking at the energy problems and working on it. We've also seen that across a number of other retail sectors and office sector particularly. Now there are big mega owners that they may own 10 to 20 buildings in a city, and instead of having one person who is not very well trained in operating systems, they may have an operator, building operator, operating 4 or 5 with central data and control. So it's making kind of a big impact on that because they see the opportunity to be able to not only maintain the buildings but also optimize their use. Energy price deregulation, I think that's kind of over, but 10 years or so ago when it was a big issue, it was affecting that because no longer do you have a single utility generating the power, providing the power to your home. It's now the generators are separate from the power line. And what it meant was prices could change a lot more rapidly and reach the market a little better. In Washington, D.C., over a 5-year period, they allowed prices to deregulate, but they went up at 10% every other year, so it was up 30% over the period. Maryland fixed the prices for 5 years, and overnight, when the cap came off, the 5-year period came off, it was 75% increase. They were screaming we have to regulate, but at that point, the prices were already been held too low for too long, so there were some shocks. Climate change mitigation, carbon regulation, no. I don't think there's any appetite for it. There was an article this morning from some economists and former Fed Reserve members, and they said that the way to get the carbon dealt with is to charge the big users for the carbon they produce, and then provide that back as a dividend to people, so that they, you know, if you were being charged that, you would do something about it. They said that would work better than any of the bottom-up situations. A lot of interest in green buildings still. USGBC celebrated its 25th anniversary, and it's looking forward to the 30th coming up. And so there's been a lot of interest in there. I'm sad to say that green buildings are probably no more than single-digit percentages. We're not seeing the massive adoption. I think it has changed the market, so there are a lot more products out there. So many buildings are greener than they used to be just because of products. BIM, widespread use of that, and kind of transition from CAD to BIM. Benchmarking and data, and this is one of the ones I'm more excited about because there's large cities, and I'll show you in just a minute, around the U.S., 25 cities would now mandate that buildings over 5,000 square feet have to provide, at various size, 5 to 50 depending on the location, have to provide their utility bills in a public database. So you see exactly, and I'll show you one example of a city. And you can access it, you can go online. Chicago's been doing this for 7 or so years now. So it's kind of interesting. And data that we, early in my career, would have died to have that much data available just because it was so difficult to get it from anybody. Now you have it and can be able to look and compare it. Zero energy buildings and communities, and I really think that's what our focus ought to be, is really pushing toward communities that are zero carbon. The other thing that's happening, IoT and smart cities. Cities have a lot of interest in this. I think we're going to see a lot more transportation. it's being driven by the ability to collect data. And it's, I think, going to be possible, and that's what all the hype is, and there's a lot of hype right now. 5G is going to drive that. And I've already seen, I see antennas here in Boise for 5G already. And they don't look like your normal big tower. They are just on a light pole and just a few things. You're going to see a lot more of that going around. The advantage of 5G is not so much speed. Yes, there's speed involved, but what the difference is that the lack of latency. So the response time will be almost instantaneous. Instead of, you type in your website on your phone and you got to wait, it'll pop up immediately. That's the advantage of 5G. And that's what will power that. Being able to control stoplights, traffic issues, other things, even get to the point where you've got cities at city scale. So there's a lot of interest there at that point. Technology is accelerating. Here we have telephone, from the late 19th century, even at 1900 was only 5%. And it took it all the way to the 70s to get over 90% penetration. Now, you start looking at other things. Radio did that in just over, not even 30 years. But you start looking, microwaves, it was 15 years. Cell phone reached that in just over 10 years. So we're seeing technology being adopted. It's making it easier today to get things. And I wish the group that did this would give us an update on it, because it does end in 2005. But there is a lot of things that are going. So you see that adoption curve is very much straight line now. And here's an example. Everything that was on this desk is now in the computer, and you can take it with you. I can work anywhere I need to, anywhere in the world, as long as I have internet. But the reality is that computer, which is a decade old, now has the same power as these phones. The phones are giving you that same sort of ability, and a much more portable possibility. Talk a little bit about some new technologies. Solid state lighting's been around for a while, but I think it's getting adopted. Prices have gotten to the point where it's almost cheaper to buy an LED light than it is to buy an old incandescent. And the good thing is, because of the technology, not restricted to the 4-foot fluorescent tubes or any of the other shapes that kind of were driving that in the past. So a lot of interesting things going on there. This is Walmart. This is probably, this is a decade ago. This is a test store that they were doing. And the marketing people said, if you put doors on the cabinets, we're going to lose people. We're not going to get as much sales. What they found is the light is more uniform, better in the LED lit cabinets. Walmart also did a test. They have occupancy sensors, because they have aisles of these. And the lights stay off unless there's somebody in the aisle. And what happens is this, because of the LEDs are using less than a quarter of the power of the old fluorescent bulbs. And in addition, the lights stay off a good chunk of the time. So they got 40% savings in their refrigerated cases, because they're not adding heat to them. Well, the doors help as well. And sales were still pretty stable. It did not disrupt sales. So they were making this pretty much the standard. Here's a super value. This is Cub Foods. Yeah, Cub Foods. Parking lot. And one of the nice things about LED lighting is how controllable it is that you can deal with it. So you look at the edge of the parking lot. It is defining the parking lot very well. It's very well lit. Feels safer. There are no big spots of dark and light. And but at the same time, they're also not projecting light out into the neighborhood and being more of a good citizen from that standpoint. So it's uses, I mean, I see it here. A lot of the street lights are already LED, partly because of the light. The efficiency is helping, but it's not all of it. I think we're going to continue to see growth in OLEDs. They're really expensive. This would be probably a $50,000 TV to be able to do this today, but the idea of being able to use something that's programmable and use that instead of a wallpaper. So like we can see things where office walls become just big screens for various things. We are seeing it. It is in the phones today. So you're beginning to see that technology. Controls and sensors, it continues to change. IoT, I really think, is the next driver, to have these devices to be able to talk, maybe to self-power themselves, so we don't have to wire them as much. And wireless is becoming kind of that area that needs to move forward. Different windows, very expensive right now, Electro, Thermo, and Photo-chromic. So light, heat, or powered. You can control the density of a system. They tend to be on the order of double what regular glazing is right now. So they're specialized cases, but if you don't want to provide shading, it's a way to deal with that. Super envelopes. Europe, it's quite common to do a double envelope where you have basically using a 2 foot wide or so space as kind of a buffer, and then conditioning that rather than waiting till it gets inside the building. And they, for a lot of places, Germany uses this a lot, seems to be of interest there. This is from Colorado. It's a perforated metal panel, and ventilation air is drawn through that. It heats up. It heats the warehouse as the cold air is. It's in the mountains near Breckenridge. An Ace Hardware.
Hey, Drew?
Yeah.
Do you happen to know what building is on the left side of the slide there? Or do you know, I think it's German, but do you know?
I'm pretty sure it's German because that's where I was seeing all the examples. I know, what's the name of the big bank in Frankfurt? They have 7-story versions of this, and I forget exactly. And then the windows in the spaces are still operable, so that if you want some of that, you could, some of the heat, or you want a different ventilation, you can do that as well. I don't, it's Deutsche Bank or one of the others, I don't remember. I visited it, it was 20 years ago, and it was kind of amazing to see what they were doing. Also, the fact that they were willing to pay for a double envelope. I don't think we get anybody willing to do it here.
Yeah, I worked in a building that looks exactly like that.
Oh, yeah?
It may be that building.
Very possible.
It's really interesting to work inside a big glass box and be able to like just see, and just the way that that double wall, double skin works is really interesting.
New insulation materials, systems, all sorts of very interesting changes have been making the envelope. Aerogel, air-based systems to try to, other ways of trapping, be able to stop energy movement have been proposed, but aerogel never really made it to the market. I think it was too costly to make. New materials and systems, kind of when I was updating this a year or so ago, I went and started looking for further things. Self-healing concretes. Concretes that'll deal with cracking, so they're somewhat fluid, not entirely, but they'll deal with the issue. Bricklaying machines, robotics in general, I think is playing a big role. It was interesting when I started looking at this, they used to have bricklaying machines in England in the 50s. So they'd lay, they're building 50 houses long. It's pretty easy just to set a machine up to lay the brick. Interesting concept. So here's this is normally a window, but when you open the window, it opens down, opens as a surface that you can stand on, provides a balcony. So if you, not sure I'd like it, but it's not quite like Chicago where you go out and stand on the glass 50 stories up. Other things, piezoelectric. This is in Rio. This is a soccer pitch as they're putting it in, and then finally, and by stepping on the panels there, and you don't have to step on them consistently, it generates enough electricity. They have power for light at night. So lots of new kind of innovative, interesting things out there. Look, materials, agricultural-based materials. I think this is a wheat straw-based fiber board, and then also used in a stucco as well. 3D printing. I thought it was cute. I saw some of the first of it about 15 years ago. I was working School of Architecture for a semester, and they were able to 3D print a model. And it wasn't very big, and it took 2 hours to print it. But it was it's cute. But I started seeing things that really changed that. So now there are machines or rigs that you can come in and 3D print a building, in this case out of concrete. And there's villages built like this now in Netherlands. I know France has a big effort toward this. You can get something 3D printed in days. I think this was maybe 9 days to get the whole building. Also, this was kind of a prototype. Oak Ridge National Lab, Tennessee, was working where they could 3D print something and then get it to the field quicker because it could then be constructed in the field. This is in Abu Dhabi. They 3D printed that building. More the 3D the printing of concrete, different methods, vertical or horizontal. So when you start to see things that you could not build in 3D, that's where it got my attention. That rather than building standard things, if I could start to build interesting structures of this scale and put them together, because a computer could do it faster than we could manufacture it. And this was probably the convincing point. This is a structural joint, and its shape is based on the structural forces. So there's material where it's needed and not, and that's metal. So 3D printed metal being used in a structure. It's strong enough to do that. That's the point at which I thought that we were really going to have a real change in its use. And I think the building industry will probably be adopting it more as we get the scale together. PV power integrated in shingles or standing metal, also integrated in glass so that you can have it as shading. Some of the more interesting, though, is I've seen this a couple times now. This is from professors at MIT, and that's a PV panel. It's transparent. So now we can consider, once we get this to scale, being able to replace our windows with PV. And so if we're drawing the power off that, we have a lot more surface area than just trying to do it.
So we'll have to go back through and demo all of our overhangs and reshade our...
No, I would leave the overhang. Big change in fuel cells. This was a Honda prototype. It was going to be natural gas fired. I think it made it to market. I'm not sure it made it here. Natural gas fired, generating heat and electricity. There's big microturbines, fuel cells, But I think more interesting has been kind of the smaller scale. That device right there in the center is the fuel cell. You put in the liquid fuel, I forget which it used, and you can have power for a week. And so that if you're trying to go somewhere where there's no power, there are opportunities. The product there at top was sold by REI. You could get it where you put in a fuel cartridge and you had a way to charge your phone in that country. Also flexible PV panels that attach. I've seen those on backpacks and things. Batteries and storage, I think, is where we've got our biggest challenge to go. Renewables are great, but the sun doesn't shine all the time and the wind doesn't blow. And so we need to be able to balance that. There's a 100 megawatt project in South Australia that is now being that balance for the electric utility down there. So they are storing the power, and it's instantaneous back out as needed. So other than building another power plant, they save a lot of money. Biomimicry, looking at nature. This is a wind turbine blade, a prototype design that was done a few years ago. How they came to that, they looked at the whale and they did computational fluid dynamics to figure out why the whale had bumps on its fin. And it reduces drag and it reduces turbulence. So it allows them to move more speedily through the water, easily through the water, less effort. And that's the kind of the idea behind that and what the CFD is proved about. So finding a solution that nature's already done, don't look at how we've done it. Nature often has a much less material and energy intensive way of getting things done. Building standards nationally are really changing. This is standard 90.1 and 189, the green building standard. And you can see big changes. For 2010, we got 18%. For 2013, 7. For 2016, 8, 6. And estimated somewhere around 3, 3.5 for the 2019. They haven't, P&L does the modeling for that, and they haven't released any values for it. What you're also seeing is the green building standard is trying to stay ahead. The interesting thing is now we are at 75% less energy intensity than we were in 1975. And that's even with all the additional equipment and everything in here. So our buildings are going to get better. The technology's already better. So, in terms of simulation, where I've spent most of my career, it's I think of it as more art than science, because the science is there. If you create a model and run the simulation, you're going to get reasonably physically accurate, with some caveats, results. The problem is knowing what the inputs are, and that understanding that. I don't see it as much as I used to, but 5 years ago, you see on email lists. I'm new to this architecture firm, and my boss just came to me and said, I need you to do the lead simulations by Friday. And because this guy had done simulations, that's what he told himself. And to me, that was like, well, we know the quality of those simulations is going to be pretty poor. Challenge is dealing with data and the model. Number of projects I worked on, just the shape of the building changed radically throughout design. Keeping up with that is really difficult. Also, keeping a model up to date once it's built, if you try to do maintenance, and usually they just don't happen. Training, you train a lot of new users how to use simulation tools, not the methods themselves. And what it means is everybody's going to say that this tool can do everything. Well, no tool can do everything. You need to see what the problem is and then find the appropriate tool for it. I think we spend a lot of time training in tools when we ought to be training in all the simulation methods. This software tends to get behind. VRF is finally making it into a lot of the tools today, but it was being hyped out there in the market as the best thing out. And there was no way to tell because I couldn't compare a VAV system to the VRF. Getting data out, we have these really elegant, robust models of our buildings, the BIM models, but getting that data to something we can use in simulation is still pretty much a challenge. I'd like to say that green building is pushing it more, but I think in reality, we're seeing things like energy standards where they're getting to the point. California reached the point about 10 years ago that you had to do a simulation model unless you were going to be willing to deal with all the really strict prescriptive requirements. So the simulation gave people flexibility in dealing with that. And that's true across the board. Trends, lots of new capability, interoperability, the IFCs, GBXML, BIM standards, way of sharing data between visualization, VR, AR. If you can visualize a building, visualize what's going on in there, owners will have a better time. I've not met many owners that were very, say, fluent in looking at drawings and floor plans, but they don't. So help them by giving visualizations. A lot of this is moving to the cloud. I kind of find it funny because when I started my career, we worked with a Boeing computer system out of Seattle, and we used an acoustic coupler with the handset and typed on a little device. Everything was in the cloud back then. And then everything became PCs, and now we're moving a lot of the big data, big analysis there. Integration among disciplines. So you may have a model that you can also reuse for CFD, electrical, visual. Insurance is very interested in simulation to be able to reduce risk. And there are a lot of models today that allow you to look at more agent-based modeling, where you're modeling people, individual people, and how they interact, and cultural things, so you can begin to look at that. Embodied energy, toxicity, emissions, all these sorts of things are coming in. So what it means is we've got a lot more tools that are customized. Some of them try to be general, and they don't do everything. But what is always kind of concerning to me is users want to be able to do more, but less effort. And I work for a software company. We put in default values in our simulation tools. And I know what those default values look like because I fixed a lot of it. But you need to know what it is that the software is presuming that you're doing, because otherwise you're trusting that software development. In terms of end-use energy, already talked about in the residential commercial sectors where you need to know more. And this was a low energy building. It's now a zero energy building, built 20 years ago, before LEED. Before LEED was really out in the marketplace. So it looks pretty good. In fact, the lights look spectacular. I would expect it to be 20 to 30% in them. And this is a small collegiate office building. Equipment, I'll explain why it's a little higher. HVAC, I'd like to know a little more detail. So we went into this project and did a complete monitoring of everything in there. You can start to look at some of all the end uses, so we know where it all went. This building was designed to be nearly zero energy. Did not have enough power, did not have enough PV to be able to do it. They didn't do a lot of analysis toward the end, and they did not focus on peak demand. This building is supposed to run the heat pumps first, and the electric boilers last. Energy savings were on the order of 74%, but the cost savings were 35%. They set the peak demand with the boiler in the winter, and that set the ratchet rate for the entire year. It cost them a lot of money, and that was just a control flip that they needed to do. Wastewater treatment, about 10% of the energy use. They have a biological system. It's an environmental studies college building, so they wanted to try this out. But the ventilation, air, and the other for that is really pushing that. Energy recovery units using energy. The energy recovery units were installed behind another duct. The original construction filters were still in place, and the only way to get a filter in and out of these energy recovery units was to break them through a 90-degree turn. So they had to move the ducts so they could service them. So that was another few percent. And this was a good building. Elevator, a couple percent. Okay, that's probably not bad. But what they found out is 90% of the elevator use was for the hydraulic fluid. They had a little heater on it that was supposed to run January to February. It ran all year long, and it used more power than the elevator. So, it's all the little things that they're going to get you. PV system consumption. At this point, there were a lot of problems with the panels were pretty good, but all the inverters and everything were bad, and we were losing about 5% of energy use in this just to drop out on the PV system. The last thing is interesting. Parking lot, sidewalk, emergency. 10 of the 13% of lighting is outside the building. What they didn't know, because it was a college, all the lights came on at sundown and stayed on all night long. Not security level, all the lights. So this, lit up like a Christmas tree. And so once they were able to do that, they were able to cut that more than half. And that was more just knowing what was going on. So you have to understand where things are happening to be able to work on them. Stuart Brand, interesting guy. He was the one who did the whole Earth catalog in the 60s and 70s. He's done a lot of interesting things, but he wrote this book, How Buildings Learn and What Happens After They're Built. One of the few times he's delved into buildings, but this quote kind of stuck out to me. You know, every building is a forecast, and every forecast is wrong. So whatever we presume in design is not how the building's going to get used. And he used a good example. This is from the cover. This is a pair of buildings, sister buildings, essentially identical, built in 1854 in New Orleans. And here they are 160 years later, same buildings. But you see, as we start to use our buildings, we change them. They need to be adapted, they need to be modified. We'll change the interiors, we'll add another floor in one case, or add the wrought iron balcony there, or we'll go classical based on style and do different things along that side. So our buildings, if you're forecasting that they're going to stay like this, they won't. And if you're forecasting they're going to be used in a certain way, probably not. So you need to be careful about your when you're doing design and other things to make sure you cover this. This is at building. The biological waste treatment there is there for that little building on the end. The water coming out of there is cleaner than the city water, but they didn't let them even use it for gray water like toilet flushing. Simulation, there was a kind of a big hubbub and cry a decade or so ago that, oh, the LEED buildings are not performing as simulated. Well, how can they? Because we don't know a lot about how it's going to be used. We have some assumptions we make, but generally you'll see we're optimistic in our simulations, and generally they use more energy, produce less power for renewables. Controls are ideal in simulation, and it works. Occupant complaints. In simulation, it's percent uncomfortable or things like that. It's not a lot of complaints, but people here will do it. And it comes down to garbage in, garbage out. The less information I have, the less likely that any simulation is going to represent a building model. This is a project I worked on almost 30 years ago, or 35 years ago. It was corporate headquarters outside Cleveland, 450,000 square feet, and we were doing energy simulation. We were a small consultant. But we did, over the period of about 2 years in this design, we did a couple hundred DO2 simulations, which was phenomenal. Normally we do 2 or 3 for a client. But we went every phase of design, went through and set budgets, and then looked at it, and then found all sorts of changes. And the real challenge we had is we started early design with very limited information, but we got increasing detail. So this is schematic design, sort of a, I don't know, a lazy L shape maybe, but that was kind of it. And we knew there was going to be sort of a central trunk HVAC, and that was kind of the information level that we had. And this was talking to the designers. They had not made decisions. So we move on to design development. It's changed a little bit. And oh, by the way, this is the point at which they told us about the 50 kW computer data center that was going to be in there. It wasn't in the program, but they added. So the energy use, as you see, went up quite a bit, but we still stayed below the target of the energy code, which was standard 90 at that point. By the time we got to construction documents, that atrium that you saw there, it got much bigger, it doubled from 5,000 to 10,000 square feet, and oh, there's an auditorium, and lots of things that really didn't play early. But we have the detail, and we're being able to, by the construction documents, that high peak is now beginning to settle out. We have more detail. But you see that change. We had to create new models every year, so we couldn't reuse data, but not most of the tool. You've got an existing building, you might have no detail, maybe no drawings. If I'm going to do takeoffs or field survey, I've got to recreate data, I'm probably going to miss something. It's just too hard to make sure you've got all of that together. I'd like to say that using the virtual data, 2D CAD or BIM is going to be the solver for this, but generally we've got robust data and very little else. Most architects I know do not. They're using it as a 3D modeling tool, not as a way to, using BIM, not as a way to convey information about each material and all the parts there. There is several efforts to do this, translating BIM to SIM. Building Smart has a standard called IFCs for translating not only energy related, but everything about the building. And I've seen where IFCs, robust IFCs have been passed from a BIM tool to cost estimating tool to a fire analysis tool back to an energy tool, and all seamless. It works, but the data has to be there, and that's been an issue. It also is limited to what the BIM tools have decided to do, and most of them have limited to geometry. There's very little else, even though it's robust electrical, mechanical systems in there. BBXML came out of California, another attempt to focus more on energy and really looking at it. Was built around trying to translate BIM to DO2 at the time, and it's now picked up other tools. Autodesk bought a Green Building Studio. They've been sort of dismantling it, pulling pieces of it into the, into Revit and other tools there. And then direct from BIM to SIM, I think, is probably where we are best. Between Autodesk, Bentley, and Graphisoft, each of them have simulation in their BIM tools now. So you've got them dealing with the interoperability and trying to make sure that the simulation is there. I think that interoperability is still a real key to getting this mainstream, but we can't really do zero energy buildings, and green buildings really kind of need it if we're going to push the envelope without it. But hopefully having this interoperability to some extent will be good. Will happen. But it's not hard really to do a lot of this today. So this is a paper, I searched for floor plans online. This was a grad student paper on using bubble diagrams to auto-generate floor plans. They had constraints on that. But what I was interested in was the floor plan. Bring it into a BIM-based tool, and PDFs, which this was, have no scale. So I have to give it one dimension, and I have to give it a north arrow. And then within 5 minutes, I can trace around the building, pop the windows in, and begin to get a model pretty quickly. And so a lot of that is helped by the BIM tools themselves, which allow a lot of formats to be entered. It's not just BIM related. Or this one, which was a digitized school and using the IFCs that I just mentioned earlier. This 1960s high school in New South Wales, Australia. And they were interested to see from the model, could they maybe naturally ventilate this? Maybe it's kind of hard to see, but in the lower right, you see kind of darker green areas. Those are high-level windows, clear story windows, and lead through the corridor so they could get some cross ventilation. That model required some cleanup because of the way they exported it, but it was gave pretty good results overall. Or, sketch something on a napkin, scan it in, take a picture. That was about, I created the first floor, and I left it crazy crooked on purpose just to show. I could have straightened things up, I could have made it more parallel. And then once you have one floor, just extruding that and creating. So that's about 5 minutes work to be able to create models today. And so the tools are making it much easier. And BIM is not like CAD. When I started out of college, the company I was with in Atlanta bought 2 of these big Intergraph machines. We had 3 shifts a day using them because the machines were so expensive we couldn't afford to let them sit idle. And but it was a very specialized tool, being able to work on that. Today, here's what works on a laptop. It doesn't require any specialized. You may want, he's got kind of a weird keyboard and a drawing thing. He's designing a golf course. So BIM is no longer just buildings. It's being able to 3D in lots of different directions. But it's also not limited to the office. You can take the models to the field and be able to look at them, compare to what's actually going on. during construction, what should be there. So BIM, started off as design and construction, but has evolved to where it's pretty much any of the infrastructure that's out there. So bridges, construction, analytics, computational design, energy performance, green, virtual design, reality modeling, asset management, IoT. And so really, we've got 3D models that we can model anything today, so they're pretty powerful. Going back to existing buildings, again, no, running late. Existing buildings, no 3D model, probably no drawings. If you have drawings, they're design or construction, there would have been changes. So again, you're going to have to do manual translation, takeoffs, and you're going to miss something. And that time would be better spent doing other things. You're really not there to create the model. You're there to use the model to make decisions or recommendations. So there are several new technologies, well, not so new. Photogrammetry has been out there quite a while, 80 years or so. But the computational power now, you can take a lot of pictures of a device as long as the camera's photo has GPS location in it, and you know what the focal length is. The software can take pictures and convert it into a mesh model. There's also, this was kind of a fun project, grew out of some DOE research. A professor at the University of California, Berkeley, had invented this backpack. It's got 2 computers on it. It's got IR cameras, regular cameras, and you walk through the space and it creates a mesh model. It also picks up heat sources pretty quickly. Part of the work was to show that this was a viable alternative. They did a test case in a 30,000 square foot building. We're able to do a walkthrough in an hour and collect all the data. When consultants went in and did the same thing, it took them a week to collect the same data, and they were within 10% of each other in the energy model. So it was kind of it's an interesting piece of work. LiDAR, much more intensive. It's been, and this is actually a LiDAR picture, not a photograph. Basically, laser scanning, being able to get a 3D model of something. This is London. They were building a new subway line, and they needed, some of these stations are 120, 130 years old, and they needed to have good, accurate drawings of them, or models. Photogrammetry, this is part of Paris. Flew with a small plane that took it back, and what it does is create an underlying mesh. The pictures are just kind of an added bonus to make it look more realistic, but that's the mesh that then is compatible with BIM that you can use on that platform as well. This is a project I was trying. We had had done a model of Philadelphia. The Pope was coming to town, and they wanted some help with security. So I thought the model was really cool. A lot of us did, but we didn't know what to do with it. Energy data, as I mentioned, the benchmarking data for the cities is, Philadelphia is one of those that has it available. So what we've done is take the data, you see the overlays and the tabs, as part of the BIM model, because this is a BIM model, and be able to, with color coding and other things, be able to look at individual buildings, sort by building type, by floor area, by energy use, all the things that are in the Philadelphia benchmarking database, but now we can do it in detail and look forward. So that's the beginning of the idea of a digital twin, is to have something that can be reused in multiple ways moving forward. There are a large number of zero energy buildings and communities going. The New Buildings Institute out of Vancouver, Washington, has been publishing a biennial update. We expect one this year. And they list ones that they can verify are operating as zero energy. See that it's been growing quite a bit over time. The green are the verified. So it's still, it's fewer than 100 in North America, but it's growing. growing quite a bit. And these are not houses that are zero energy, more commercial. And you see the count on that. And so this is a recent one that I just pulled off. As you can see, a lot in California, a whole lot easier to do in California. But even up into Canada and pretty much all over the US, except for with a couple exceptions. But still, it's possible to do an operating zero energy building all over the climates of that. So, no. Not unless your owner wants you to do something crazy and build. This is actually, I think this is a house that it's one of the French designers, maybe Pierre Cardin owns. But he wanted something crazy on the Côte d'Azur, the Riviera, and so it built. You can actually rent this, I found out. I've been using the picture for a long time, and then I found out you could rent the building for mere $10,000 a week or something. But there's no reason that any of this technology is going to push us to that. We're not looking at space age stuff. NREL has a research support facility. It's the middle part of the larger picture. Those three wings. It's been operating at zero energy for a decade. So it has been. It's not a lot different. There's more attention to window shading and other things. It wasn't enough to cover the three roofs with PV, though. That parking lot to the right had to have that to be added. But it has a large data center in it and some other things that make it possible. So we're going to see things with more renewables integrated. Or military base in Hawaii, electric rates are over 20 cents a kilowatt hour. On Oahu, it's more on some of the other islands. So hot water and PV pay for themselves almost immediately. Walgreens did a prototype store, very different from standard drugstore. Building in Seattle, the Bullitt Center, operating at zero. Has a big canopy, though, to be able to get enough PV on that. Apple, supposedly, one of those sets of rings are PV panels, but I've heard nothing about it. What I've heard is that people keep walking into this curved glass, the curve there. They actually put curved glass in the building, so people keep walking into it because they can't see it. That's about all you hear about the building. So we'll hope to hear more. So we've got a lot going on in technology. It's accelerating. I think it's beginning to hit buildings industry pretty well. Robotics are going to play a big role moving forward. We've got new software capabilities, making it easier to create models. Getting data through interoperability from BIM is still pretty much a challenge. I have a friend who works in LA, and he is expert at working in the Revit side first and cleaning the Revit model up so that when he exports it, his model is ready to go. I have not seen one of that, but he's learned to do what it takes to get the model right on the architectural drawing side before he moves forward, and it's pretty amazing. LiDAR photogrammetry. Photogrammetry is great for outside. It does not like windows. It does not like transparent surfaces very well, so it doesn't work well. LiDAR does that. I've seen LiDAR used in mechanical rooms to be able to capture 3D models of everything in a mechanical. It's all only as good as the data you enter and how much detail you put in. Garbage in, garbage out. So better quality data means better quality results. Simulation is powerful, but you really need to be able to have the data there to be able to make its power seen. And if you're doing evaluation comparison of things throughout the building life cycle, that's really what the strength of the tool is. So my career started out where I was really focused on energy, reducing energy, looking at peak demand, keeping it down, and looking at capital and operating costs. But I've learned over time with the project I showed you with the biological wastewater treatment, that there are other things that we need to be looking at, and if we're not, we're going to miss something. Water was a case, that building that I mentioned that it didn't get the energy cost saving, that's because they forgot to look at demand. Indoor environmental quality, you can have a fail if you're not worried about daylighting and glare and control of all of that. Carbon's kind of an offset of that. It still can be calculated, but sometimes that's important to users. The other part of it was that I found that I needed to understand the business model of the people I'm working with. If it's a school, they're probably interested, what does it cost per student to build and operate a building? So if you, instead of working in terms of per square foot, you work in terms of that unit. Hotels, it's revenue per occupied room. Don't tell them square foot. They don't, that's not how, they know they have 150 rooms and made X $1 billion last year. You need to translate that into something. Sales pretty easy because their metric is per square foot. That's how they measure. Interesting one, a brewery and a winery both are reporting energy and carbon savings in terms of per barrel of beer produced. So they're really committed to doing it. At the same time, they publish this in their annual report. So find out what the model is and do it better. I think that's it. Thank you.
We're a bit over time, but there is some room for questions. But before you go, just be sure to fill out an evaluation if you would. If you haven't put your name on a raffle ticket, drop that in and we'll contact you afterwards if you win. And most importantly, a thank you to Idaho Power for sponsoring this lecture and this lunch. And now I'll put Drew back in the hot seat so he can ask questions.
I'm happy to answer a few questions. I have a flight that leaves in an hour and 19 minutes. Oh, I know. I got Ken ready.
What's going on with standard 205, the standard HVAC performance data?
They've actually had a public review that completed recently. I see some of the, I think they're going to go back out for not the whole standard again, but some changes. That should probably hit this spring. You can get on their mailing list if you're interested. You can join. It's been a long haul because the manufacturers weren't really ready to release a lot of the data that was really possible.
Yeah, I know.
On that big project in Cleveland, the 450,000 square foot, we put in the contract that they needed alternate bids on at least 2 different chillers. And if the chiller manufacturers didn't give us the data, they didn't get the bid. That was the only way we got curves for the specific chillers.
Did they supply you curves or
Yes.
data?
They supply curves.
So you talked a little bit about 3D printing. Is there, I know that like modular design and having some of those construction methods, controlling, having those at like a big warehouses and control environments, is there enough science right now to be able to have any sort of like scientific data as to whether or not prefabbing apartment buildings or houses is going to make a dent into the energy consumption or energy savings?
Not so much on energy, but I know there's a new 40-story hotel going in Manhattan, and it's supposed to be constructed in a week because each floor or all the pieces of it are modular, so they're able to do all the quality control in a control warehouse situation. So it's much faster for them to do. They're not having to dangle off the building to do things. I have not seen anything about what the energy impacts of that will be. I know that if you have systems that are manufactured off-site and then brought together, and I've seen various housing, you wind up with much better, much tighter buildings. But I haven't seen any data.
I'll follow you on Twitter and I guess
Please.
for that.
Please. Anybody else? Thank you for,
One more. I saw the winter conferences a couple weeks ago,
Yeah.
which I didn't go to, but there was a debate which looked interesting about whether efficiency matters in
and
a
a zero
carbon
energy
world, and like, which I know is like a little bit far-fetched, but at the same time, like, levelized cost of energy of solar, of utility solar is like going underneath
Yeah.
conventional as it is.
Right.
If like storage follows that, so we like get past the duck curve. Like it doesn't seem like it's that far-fetched. Just curious if you have thoughts about on that question.
Well, there still is a cost of energy. I mean, whether you're installing the PV or you're getting it from a utility, there's still a cost associated with getting the power through the lines or installing the system. So the more efficient you make the building, the less you have to do with that. And I think that's really the key. Yeah, it's the College of Fellows does these debates every time, and they're kind of fun. I did one 6 months ago, I forget. We were talking for and against climate change. And we weren't told which side we got until we got up on the podium.
Cool.
So it was, of course, I didn't get the one that I liked to say. So, anybody else? If something comes up, you got my email, I'm happy to talk to you all offline.
Thank you very much.